Hi everyone, in this video I am going to solve A-Levels Pure Mathematics Paper 1 in a session February-March 2024 Paper 1-2. So let's start with the first question. Question number 1, find the exact value of this integral. So we have to integrate. For this we have to put the constant to outside and shift the 1 over x square to the numerator. This becomes x to the power minus 2 and dx. And this is the definite integral from 3 to infinity, and 2 is outside. The integration of x to the power minus 2 is minus 2 plus 1 over minus 2 plus 1, and the limits I'm going to put 3 to infinity. We are not adding c because this is a definite integral. Okay, so this is 2 x to the power minus 1 over minus 1, and the limits are from 3 to infinity, and we have 2 and minus 1 over x. I shifted x power minus 1 to the denominator, so minus 1 over x, and the limits are from 3 to infinity. Alright, so this is minus 2 over x. This is from 3 to infinity. Now let me substitute the limits. So minus 2 over infinity and plus 2 over 3. Okay, so what I did, I substitute the upper limit, which is infinity, in place of x, and the lower limit, which is 3. So upper limit is infinity, subtract the lower limit, so minus and minus becomes that plus. Okay, so something divided by infinity is 0 and plus 2 by 3. So 0 plus 2 by 3, the answer is just 2 by 3. Alright. Question number 2, the diagram shows part of the curve with equation y equals to k sine half x, where k is a positive constant and x is measured in radians. The curve has a minimum point at A. A is the minimum point of the curve. Number A, state the coordinates of A. We have to state the x and the y coordinate of A, and we have given that this is the minimum point. And we know that the formula of minimum in sinusoidal function, sine or cosine function, its formula is equation of x's minus amplitude. So as you can see in this equation, the equation of x's is 0 and minus the amplitude is k. So this is minus k. This is the y coordinate. We can say this is the y coordinate. All right. So in sine and cosine, in sinusoidal function, the formula of minimum is equation of x's minus a. Let me write down the transformed form is a sine bx plus c. All right, so the a is amplitude, c is the equation of x, is c equation of x is subtract amplitude, we will get the minimum. Since we have the minimum, and that would be the y coordinate, the formula is the y coordinate. Now we have the y coordinate, let me solve the x coordinate now. So to get the x coordinate, so let me substitute that y equals to minus k into this equation and solving for x. Now for x coordinate, what I'm gonna do is I have to substitute y equals to k sine half x. All right, so let me simplify this on a separate paper because I don't have much space. So we can say y is negative of k, so negative k equals to k sine half x. So this k and k is cancel, minus 1 equals to sine half x, or we can say sine half x equals to negative 1. Now in this equation sine is negative, so now let me check in which quadrant sine is negative using the cast rule. If I can draw. Okay, so according to the cast rule, C, A, S and T. Here all positive, here sine is positive, tangent positive, and cosine is positive. In this equation, sine is negative of something. So sine is negative in the third quadrant and sine is negative in the fourth quadrant. And what are the operations of third and fourth quadrant in terms of radians? So we have theta, here pi minus theta, Here we have pi plus theta, and here we have 2 pi minus theta. So we have to apply these operations, pi plus theta and 2 pi minus theta. Alright, so let me simplify. What is half x? Half x is going to be sine inverse of 1. We have to solve for 1 first. It should be in radians. My calculator is in radians. Sine inverse of 1 is pi by 2. Okay, so we can say half of x is pi by 2. Alright. Okay, so this value is pi by 2. Now this is representing as theta, right? This value is representing as a theta. Alright, now pi plus theta and 2 pi minus theta we have to apply. So for the third quadrant, we can say sine is negative in the third quadrant. The operation for the third quadrant is pi plus theta. So pi plus theta value is pi by 2. So pi plus pi by 2 is 3 pi by 2. Right? And sine is also negative in the fourth quadrant as well. So for the fourth quadrant, we can do 2 pi minus pi by 2. So 2 times 2 would be 4, and 4 minus 1. Okay, you can say 2 pi minus pi by 2. This is 3 pi by 2. This is again 3 pi by 2. Alright, 3 pi by 2, 3 pi by 2, and pi by 2. So these are the values of half x. So we can say 1 by 2x is equals to pi by 2 and 3 pi by 2. And what are the solutions? So let me solve for x. So x is equals to pi, cancel the 2, or we can say x is equals to, cancel the 2, we have 3 pi. Let me check which is the coordinate of x. So look at the periodic function, the sine function, right? So this equation says k sine half x. So we have the minimum point is k, negative k is the minimum point. So it means the maximum is positive of k. All right. Okay. So what is the period? We have given the coefficient of x. The formula for period in terms of radians, because it is measured in radian, which is 2 pi over the coefficient of x, which is half. So that is equals to 4 pi. One complete cycle is the period. The cycle starts from 0 and then again at 0. This is the one complete cycle. So from 0, this is 4 pi. If this is 4 pi and this is symmetric, this would be equals to 2 pi. 0 to 2 pi, 2 pi to 4 pi, 4 pi to, this would be equals to 6 pi. So it means in the middle, we have the minimum x coordinate is 3 pi. We are not using pi because pi lies over here. So that is why we are using 3 pi. So we can say the coordinates of A, the x coordinate is 3 pi and the y coordinate is negative of k. I hope this makes sense now. Okay. So this is just a 1 mark question. So there is no need to do the question in detail. So I did each and every step just for the understanding. So the main concept here is we have to find the minimum point, the x and the y coordinate. So as we know, for the y coordinate, the minimum formula is equation of x is minus the amplitude we did, and you will get the minimum, the y coordinate of the minimum point. All right. And to get the x coordinate, you can easily use the formula for the period, since x is measured in radians. So the formula for period of the sine function is 2 pi over the coefficient of b. That is the formula. So we have the period, and we know that the period is one complete cycle. From this point to this point is one complete cycle, and one complete cycle contain one maximum and one minimum. All right. Okay, so this is 0, this is 4 pi. Since the periodic function is symmetrical, so this is 4 pi, this must be 2 pi, and in the middle we have pi and 3 pi. So this is obvious that the minimum x coordinate is 3 pi and the maximum x coordinate is pi. Okay, now moving to part B, sequence of transformation is applied to the curve in the following order: translation of two units in the negative y direction, reflection in the x-axis, find the equation of new curve, and determine the coordinates of the point on the new curve corresponding to A. Okay, so we have the equation y equals to k sine half x. A sequence of transformation is applied to the curve in the following order. The first is translation, two units in the negative y direction. It's negative 2 units, and y direction, the vertical, y is in the vertical. So it means we have a vertical translation. We have a vertical translation and it is 2 units negative. So it means 2 units down is the vertical translation. So y is equals to k sine half x minus 2. So this is a translation 2 units in negative y direction. Y direction, it means we have a vertical translation. For vertical translation, we have to add or subtract something. So it is 2 units. So we added or subtract 2 and it is negative. So I did the negative one. Reflection in x-axis. When we have to reflect something in x-axis, look over here. This is x-axis. When we are doing reflection of this to the x-axis, it means the y coordinate changes, the x coordinate stays the same. So y becomes negative. So this whole y becomes negative. So y equals to negative of k sine half x minus 2. So y equals to 2 minus k sine half x. So that is the equation of the new curve, right? This is the equation of the new curve after applying a series of transformations, right? Now we have to determine the coordinates of the point on the new curve corresponding to A, all right? So before, the coordinate of A is 3 pi and negative of k. Now, what happened over here? Now, first we have applied the translation 2 units down. So this 2 units down, the vertical translation 2 units down, from minus k, it moving minus 2 down. So minus k minus 2, we have to move 2 units down, and then we have to reflect this to x-axis, reflection in x-axis. So it is k plus 2 and the x coordinate stays the same. So we can say the coordinate of A is 3 pi and k plus 2. Let me explain one more time. Since we are just dealing with the vertical translation and the reflection in x-axis. So whenever we have a reflection in x-axis, the y value signs switches. And when we have a vertical translation, the y value changes. It means the x stays the same. So the x coordinate 3 pi stays the same, right? So first thing first, we have to apply the translation 2 units down. So when we have the minimum y coordinate is minus k, and when we are moving 2 units of down, so in minus k we subtract minus 2. So minus k minus 2 would be the y, and the x is 3 pi, it stays the same. The next minus k minus 2, we have to reflect this in x-axis. So it becomes positive k and positive 2. I hope this makes sense now. So 3 pi and k plus 2 are the coordinates of point A after applying a new transformations. Question number 3, a curve is such that its first derivative is given. It is given that the point 1, 9 and 5a lies on the curve. It lies on the curve. Curve means in terms of y we have to find the value of a. So we have dy by dx. First we have to find the equation of curve. So for the equation of curve, we have to differentiate. So we have dy over dx equals to 3 into 4x plus 5, its whole power is 1 by 2. We have to integrate both sides with respect to dx. Okay, so this dx and dx is cancel out, this derivative and integral is cancel out. We have y equals to 3 is outside. We have 4x plus 5 and its power. So applying the power rule, and its derivative is going to divide. Yes. Or let me complete the derivative first by multiplying and dividing by 4. 4x plus 5, its power is 1 by 2 dx. Okay, so y equals to 3 by 4 is outside, integration 4 and 4x plus 5. So we can apply the integration when we have the derivative is completed. This term derivative is 4 and it is already completed. So we can apply the integration now. We have 3 by 4 and 4x plus 5. Its power is 1 by 2 plus 1 over 1 by 2 plus 1 plus some constant of integration. 1 by 2 plus 1 is 3 by 2. So y would be 3 by 4. 4x plus 5 is 3 by 2 divided by 3 by 2 plus some constant of integration. So y equals to 3 by 4 times the reciprocal of this is 2 by 3 and 4x plus 5 is 3 by 2 plus some constant of integration. 3 is cancelled with 3. 2 times 1 is 2. 2 times 2 would be 4 and 1 by 2 is the answer. So 1 by 2 into 4x plus 5. Its power is 3 by 2 plus some constant of integration. Alright. The curve is such that it is given that these 2 points lies on the curve. Find the value of A. So point 1, 9 and 5A. So if 1, 9 lies on A, the curve, it's much satisfied. So 1 and 9. So x is 1, y value is 9. Let me solve for C. 9, 1 by 2 into 4 times 1 plus 5, 3 by 2 plus C. Let me solve for C. So this is 9. Okay. 4 times 1 is 4 and 4 plus 5 is 9 and 9 to the power of 3 by 2 is 27. 27 divided by 2 and it shifted over here is minus 27 by 2 and 9 subtract answer is minus 9 by 2. This is the C value. Minus 9 by 2 is the C value. Let me rewrite. So y equals to half 4x plus 5 to the power of 3 by 2 minus 9 by 2. Now 5 and A, this point also lies on the curve. We have to solve for A. Okay, so 5 and A, it means x value is 5 and the y value is A. We have to solve for A. So y is A and x is 5. 1 by 2 into 4 times 5 is 20 plus 5 to the power of 3 by 2 minus 9 by 2. Let me calculate this. So we have 4 times 5 plus 5. Its power is 3 by 2. 125 divided by 2 and subtract 9 by 2. A value is 58. So here A is 58. Question number 4, part A. We have to prove left hand side equals to right hand side. Let me start from the left hand side. We have sine square theta plus cos square theta plus 2 into sine theta and cos theta. What I did over here, I opened the squared. I used the formula of a plus b whole square. A plus b whole square. This is equals to a square plus b square plus 2ab. So a over here is sine theta and b is cos theta. So first term square, second term square plus 2 times first term times second term. Alright, and then subtracting 1 and whole term is going to divide with cos square theta. And we have the identity that sine square theta plus cos square theta, this is equals to 1. So means this term is equals to 1. Alright, so this is 1 plus 2 sine theta cos theta minus 1 divides cos square theta. So positive 1 and negative 1 is cancel out. We are just left with 2 sine theta cos theta divides cos of square theta. Now cancel the cos and with this cos and we are just left with 2 sine theta over cos theta. And sine over cos is tan theta. So this is 2 tan theta. This is my right hand side. It is proved. Okay. Now for part B, hence solve the equation. This whole equation equals to 5 tan cube theta, for theta is between minus 90 to plus 90, and this whole thing we know is 2 tan theta, and this is equals to 5 tan cube theta. So we can say 2 over 5, and here tan cube theta over tan theta. I did the cross multiplication. Tan theta over here and 5 over here. So we can say this tan and this is square. So we can say tan of square theta is equals to 2 by 5. And what is tan theta? Tan theta is plus minus square root of 2 by 5. All right. Now apply the cast rule and check tangent is positive and negative in which quadrant. We are dealing with two cases now, with the positive one and with the negative one. Okay, so according to the cast rule, C, A, S, and T. Okay, so here we have theta, here we have 180 degree minus theta, 180 degree plus theta, and 360 degree minus theta, right? So tangent is positive in the first quadrant and in the third quadrant, and it is negative in the second and fourth quadrant. Yes, so we have the two equations. Let me work on it. The two cases, sorry, not the two equations. So in the first case, we can say tan theta is equals to square root of 2 by 5, the positive one. And in the second case, tan theta equals to negative square root of 2 by 5. All right. So theta equals to tangent inverse of root 2 by 5. And here theta equals to tangent inverse of root 2 by 5. We have to solve for the positive, and then we have to check in which quadrant it is negative, second and fourth, sorry. All right, now let me simplify in terms of degrees. Our domain is in degrees, so let me convert your calculator into degrees first, and then we have to complete tangent inverse square root 2 by 5. Okay, this is 32.3. So theta equals to 32.3. All right. And tangent is positive in the first quadrant. So 32.3 is in the first quadrant, and in the third quadrant we have to 180 plus that answer. This is 212.3, and this is more. Our answer should be in between minus 90 and plus 90. So we cannot take the second one. And over here again theta would be equals to 32.3, and it should be in the second and fourth quadrant. So for the second quadrant we can do 180 minus 32.3, which is 147.7, which is also more. Between it not lies between minus 90 and plus 90 degree. And 360 minus 32.2, 32.3. This is again more than the domain. So that is the one solution, 32.3. And I messed up, I guess, because in these questions we cannot cancel the tangent, sines or cosines. We have to take them common. It is better. So let me explain this over here. So 2 tan theta minus 5 tan cube theta equals to 0. So tan theta is common, and we have 2 minus 5 tan cube theta. This is equal tan square theta. This is equals to 0. So we have tan theta equals to 0 is the first one, and 2 minus 5 tan square theta. This is equals to 0, or we can say minus 5 tangent square. This is minus 2. So negative is cancelled with negative, and we have tangent of square theta is 2 by 5. And we can say tangent of theta is plus minus root 2 by 5. We have done with plus minus root 2 by 5. So what is theta equals to tangent inverse of 0 in degrees we are working on. Tangent inverse of 0 is 0. So this theta value is 0, and tangent here, tangent is also positive, and this 180 minus 0 plus 0 is 180, which is not lies in the domain we have given. So we have a solution 0 and 32.3. This solution. Question number 5. A curve has an equation y equals to this. Find the equation of normal to the curve at a point 2, 1, giving your answer in the form of ax plus by plus c equals to 0, where a, b, c should be integers. Okay, we have to find equation of normal. So first let me write down what is equation of normal. Equation of normal is y minus y naught equals to negative 1 over m at the point x into x minus x naught. Okay, so this point is x naught and y naught. We have x naught, y naught, but we don't know m. M is basically the gradient or the slope. Gradient, or we can say the slope, is dy over dx at x is equals to 2. We have to solve. Okay, so here we have to apply the quotient rule we can do, but if I can shift this term to the numerator, so 2x square minus 5, its power is negative 1. So 3 is outside. Applying the power rule, so first we have to write down the power, the base function, and power minus 1, and the derivative of the base function, which is 2x square minus 5. Okay, in the next step, what is dy over dx? This is going to be 3 minus 1. We have 2x square minus 5, its power is negative 2, and its derivative is 4x. 2 times 2 would be 4, and just x, 4x, right? Now dy over dx, this is 4 times 3 is 12, and negative 12x over 2x square minus 5, its whole square. That is the derivative. And we can say dy over dx, this is equals to, at x is equals to 2. We have to solve. So 12 times of 2 over negative is outside, right? 2 into 4 minus 5, its whole square. I did the 2 square is 4, right? So 12 times 2, this would be 24, negative of 24. And 2 times 4 is 8, minus 5, its square is 9. So minus 24 over 9. Negative 24 by 9 is negative 8 over 3. That is the slope, right? Now let me write down the equation of normal. We can say equation of normal. The equation of normal is y minus y naught is 1 equals to negative, and its reciprocal, 1 over minus 8 over 3 into x minus x naught is 2. Okay, so this is y minus 1, and this is negative times negative is positive, and the reciprocal of 8 by 3 is 3 by 8, and x minus 2. Okay, now cross multiply, we can say 8 is multiplying over here y minus 1, and 3 is multiplying with x minus 2. So 8y minus 8 equals to 3x minus 3 times 2 is 6. We have to write the answer in this form, ax plus by plus c. Okay, so shifting the terms over here, 0 equals to 3x, minus 6 is as it is, shifting these terms, minus 8y and positive 8, right? Or we can say 3x minus 8y, and from 8 take away 6 is positive 2. This is equals to 0. And now this is in the form of ax plus by plus c, and a, b, c are integers, which is 3, negative 8 and positive 2. So this is the equation of normal. Question number 6, it is given that the coefficient of x cube in the expansion of this is 432. Find the value of a constant a. We have to find the coefficient of x cube first in this expansion. So let me expand this. Its power is, let me just work on this, 2 plus ax to the power of 4. So the first term is 2 to the power 4 plus 4c1, 2 to the power of 3, and ax to the power of 1 plus 4c2, 2 to the power of 2, and ax, its power is 2, and plus so on. Okay, let me open the rest of the terms as well. We have 4c 1, 2 and 3 over here, 2 to the power 3, and ax to the power 0, 1, 2, and 2 to the power 1 over here. This power is 3. because the first term powers are decreasing 4, 3, 2, 1, and the second term powers increasing 1, 2, 3. Okay, and then 4c4, 2 to the power 0 and ax to the power of 4. Okay, so simplify a plus 2 plus ax to the power of 4. This is 2 to the power of 4 is 16. Okay, 4c1 is 4 times 2 cube. Okay, 32ax. Now this term 4c2 times 2 square. Okay, which is 24 a square x square. The third term is 4c3 times by 2 is 8 a cube x cube. 8 a cube x cube. 4c4 is 1 times 2 to the power of 0 is 1. So this is just a4x4. Okay, now let me do its product with 5 minus ax, right? So 2a, okay, this term and its product with 5 minus ax. So first we have to multiply throughout the equation with 5, and now no need to do the whole distribution. So let's find just the work on the coefficient of x cube. And 5 is multiplying with this term. 5 is multiplying with a plus 2x whole to the power 4, and minus ax is multiplying with 2 plus ax to the power of 4, right? So first multiply with 5, 5, 5 and 5. When we are multiplying this term with 5, we will get the coefficient of x cube. We can say coefficient of x cube. Let's just work on the coefficient of x cube. It means for 5 is multiplying with this expansion. I'm explaining one more time. 5 constant term, x square term, x cube term. Here we will get 5 is multiplying with 8 a cube x cube, right? Minus ax. This is 16 minus ax. This is 32 minus a square x square. This is going to be x square term, and this is going to be x cube term. So minus ax multiplying with 24 a square x square, and here we have x4 term and x to the power 5 term. So these are the two terms of x cube. Okay, 5 times 8 would be 40 a cube x cube minus 24 a cube and x cube, right? Now we can say 40 minus 24. 40 minus 24 is 16. 16 a cube and x cube. Okay, and now we have given that the coefficient of x cube is 432. Okay, now according to the question, x cube coefficient is 16 a cube, and this is equals to 432, and we have to just solve for a. So a cube over here is 432 divide 16. 432 divide 16. This is 27. So a cube is 27. It means it is a cube root of 27, which is 3. So a equals to cube root of 27, and a value is equals to 3. We have to find the constant a, which is equals to 3. Question number 7. A straight line meets the curve at a single point P at one point. When it is meeting at single point, it means the discriminant b square minus 4ac should be equals to 0. When it meets at 2 points, the discriminant should be positive. When it never meets, its discriminant is negative. Number A, find the value of k. So the line and the curve meet. So y is x plus 5. Substitute over here. 2x square plus 3. The y is x plus 5. Its whole square equals to k. 2x square plus 3 x square plus 5 square is 25, plus 2 times 5 times x is 10x. This is equals to k. So 2x square plus 3x square, and 3 times of 25 is 75, plus 75 plus 30x, and negative k equals to 0. Shift the k on the other side. So 2 plus 3 would be 5x square and the x is just 30x, and the constant is 75 minus k. This is equals to 0. This is a quadratic equation. When the line and the curve meet at a single point, it means its discriminant should be equals to 0. So we can say discriminant, which is b square minus 4ac, this should be equals to 0, and here we can easily get the k value, right? Okay, so b value is 30, so 30 its whole square minus 4, a value is 5, and the c value is 75 minus k. This is equals to 0. So what is 30 square? 900, and 4 times 5 is 20. So 20 into 75 minus k equals to 0. So 20 times 75 is 1500. So 900 minus 1500. Negative times negative is positive, 20k equals to 0. Okay, so from 900 minus 1500, this is minus 600. So 20k minus 600 equals to 0. 20k equals to 600, and k equals to 600 divided by 2. Divided by 2 is 300. So the k value is, divided by 20. 2 times 3 is 6, and 0 it is 30. So the k value is 30. Okay. Now for part B, find the coordinates of P. The coordinates of P we have to work on. Now let me substitute the k over here, which is 5x square plus 30x and plus 75 minus k, which is 75 minus 30 is 45, equals to 0, right? So we have given that the straight line and the curve meet at a point P. We have to find the coordinates of P. So this equation we made when the straight line and the curve meet. So let me solve for x. So the x coordinates, right? Applying the quadratic formula, or let me divide throughout the equation by 5, because to simplify. X square 5 times 6 is 30, and 5 times 9 is 45 equals to 0. This is x square plus 2 times 3 times x plus this is 3 square. So here we can use a formula of x plus 3 whole square. So the factor A, or we can say x plus 3 would be equals to 0, or x is equals to negative 3. So x coordinate is negative 3. Let me solve for the y coordinate by substituting into y equals to x plus 5, the equation of a straight line. So y equals to negative 3 and plus 5, so the y coordinate is 2, right? So we can say the coordinates of P are minus 3 and 2. Question number 8, part A. An arithmetic progression is such that its first term is 6 and its 10th term is 19.5. Find the sum of the first 100 terms of this arithmetic progression. We have to find what is S100. Right, so A we have given is 6 and A10 we have given is 19.5. all right, what is AN? AN is A plus N minus 1 into D. So what is A10? Which is equals to A plus 9D. Okay, so A10 is 19.5, A is equals to 6 plus 9D. Let me solve the common difference. 19.5 minus 6 divided by 9, this is my D. Let me simplify. 19.5 minus 6 and divided by 9, this is 1.5 is the D. So D is equals to 1.5. We have A, we have D. Let me solve the sum of first 100 term. We have Sn equals to n by 2 into 2A plus n minus 1 into D. Alright, so S100 is 100 by 2 into 2 times of 6 plus 100 minus 1, and the D is 1.5. Let me just simplify. Okay, so 2 times 6 is 12. 100 minus 1 is 99 times 1.5, and add 12 and times by 100 divided by 2, which is 8025. So we can say the sum of first 100 terms are 8025. Right. Now moving to part B. A geometric progression a1, a2, a3 and so on is such that its first term is 24 and the common ratio is 1 by 2. The sum to infinity of this geometric progression is denoted by S. This is sum to infinity. The sum to infinity of the even number terms a2, a4, a6 is denoted by SE. Find the value of S and SE. First, let me work on S infinity. The sum to infinity has a formula a over 1 minus r. So a is the first term, which is 24, over 1 minus r is half. 1 minus 1 by 2 and 24 divides answer. This is 48. So the sum to infinity is 48 and we have to find the even terms first, right? So if a1, a2, a3, a4, a5, a6 and so on. Let me write down these terms. a1 is 24 and each term is divided by 2, the common ratio. So 24 divided by 2 is 12. 12 by 2 is 6. 6 by 2 is 3. Okay, divided by 2, divided by 2, divided by 2 is 1.5. Divided by 2 is 0.75. Now we have to pick the even terms. What are the even terms? Even terms are a2, which is 12, a4, which is 3, and a6, which is 0.75. Let me write down the common ratio r, which is 3 by 12, or we can say r is equals to 0.75 over 3. Okay, what is 3 by 12 is 1 by 4. 0.75 over 3 is 1 by 4. So here r is 1 by 4. Right. Now the sum to infinity of even terms SE, this is again a over 1 minus r. Now the first term is 12 over 1 minus 1 by 4. So 1 minus 1 by 4 and 12 divides answer, which is 16. This is 16. Question number 9. The function f and g are defined for all real values of x. F of x and g of x. The domain we have given that x belongs to all real numbers, where k is a constant. Number A, given that the range of the function g composition f is greater than equals to 39, find the value of k. So first let me find out g f of x. Okay, so we have g and f of x is 3x minus 2 its whole square plus k, right? And g f of x is going to be, we have g of this, so 5, and then this is 3x minus 2 whole square plus k and minus 1. Okay, let me simplify this. 5 into 3x minus 2 its whole square plus 5k and minus 1. Okay, so this is the factored form of a quadratic equation. So we can say, the vertex form. Vertex form, we can write down the vertex form as y equals to a x minus h whole square plus k. And the range of the vertex form is always, the range is less than equals to or greater than equals to the k value. That is a formula for the range of the vertex form, right? Okay, so what is the k value? So a is 5 and x minus h is basically 3x minus 2 whole square, and this is going to be the k in our case. So it is great, this value, the range is greater than equals to this value. So this is 39. So it means this value is equal to 39. So from here we can say 5k minus 1 equals to 39, and 5k equals to 39 plus 1 is 40. So 5k equals to 40 and k equals to 40 over 5, and 5 times 8 is 40. K equals to 8. Right. Now for part B, for this value of k, determine the range of the function f g of x. Okay, so first we have to find f g of x. So we have f and g of x. We have f g of x is 5x minus 1, and f of something is 3 into 5x minus 1, its square, minus 2, and its whole square, plus k, because f of x is 3x minus 2, so x is replacing with 5x minus 1, right? K value is 8. Okay, so this again look like in the vertex form, ax minus h whole square plus k. So its range is obviously less than equals to or greater than equals to the k value. Since the coefficient of x square, when you open this, we'll get the x square, 5x whole square. So its coefficient is positive. So the range is greater than equals to the k value. So we can say f g is greater than equals to 8. That is the range. The k value is 8. Now for part C, the function h is defined for all real values of x and is such that gh of x is this. Find an expression for g inverse and hence or otherwise find an expression for each. So first work on g inverse. We have g of x is equals to 5x minus 1 we have given. So for g inverse of x, we can say y equals to g of x. Switching the variables, x equals to 5, y minus 1, solving for y, x plus 1 divided by 5, this is my y, and that is my g inverse of x. Alright, now we have g h of x. This is equals to 35x plus 19. Let me solve for h of x, right? Okay, so h of x is going to be 35x plus 19 into g inverse of x, multiplying by g inverse on both sides to get the h value, right? So h of x is going to be 35x plus 19 into x minus 1 over 5. Okay, so make a simplified expression. This said, hence it means using g inverse or otherwise just find the expression for h of x. If I used g inverse, it get complicated, so let me use the otherwise way. Okay, not this one I'm working. Okay, so g h of x is equals to 35x plus 19. So we have given g of x is 5x minus 1. Now g x is replacing with h of x, right? G of x is 5x minus 1. This is 35x plus 19. Okay, 5 h of x equals to 35x minus 19 and plus 19 and plus 1, which is equals to 20. So h of x is 35x plus 20 and whole term is going to divide by 5. 5 times 7 is 35 and 5 times 4 is 20. That is the expression for h of x, which is 7x plus 4. And in this b part, you have to convert this into the vertex form. So by doing so, we can say 3 times 5 is 15x and 3 times 1 is 3, and then we have minus 2 its whole square and plus k, and further we have 15x and plus negative 5 its whole square and plus k is the 8, right? So now this is in the vertex form. We can say we have a x minus h whole square plus k. So a, the coefficient is positive, it's 1, so it is greater than equals to the k value, which is 8. I hope this makes sense now. Question number 10, the diagram shows a circle with the center C, which is negative 4 and 5. So this is minus 4 and 5. Okay, and radius is square root of 20 units. This is root 20. The radius, this radius is also root 20. Means from C to A, C to B is root 20. The circle intersects the y-axis at points A and B. If it intersects the y-axis, it means its x component is 0. 0 times some y, and this also 0 times some y. All right. The size of the angle ACB, AC and B is theta radians. Number A, find the equation of tangent to the circle at point -6 and 9. Equation of tangent to the circle. So we have the equation of tangent to the circle, which is y minus y naught equals to m into x minus x naught. So we have the point x naught and y naught, which is -6 and -6 and 9. We have to solve for m. Okay, so as we know, this point is equals to, this point is 4, right? Let's say this point is 6, -6, and we have this point is 5. Let's say somewhere over here we have a point of 9. So -6 and 9 lies on this point, -6 and 9. This much lies on the circle, because tangent is a point which touch the circle at only one point. Okay, so this is a tangent. I drew the tangent. We have to find the equation of tangent to the circle. From this information, we know that we have to find the equation of tangent to the circle. At this point, we have to draw the tangent which touch the circle at one point. And we know that the tangent is always perpendicular to the radius. This tangent is perpendicular to the radius. According to the theorem, the tangent is perpendicular to the radius. Okay, so if we can find out the slope of this line, we can do negative reciprocal, we will get the slope of this line. So the line C to this point, which is -4, 5, -6, 9, let me find out the slope. So we can say the slope, or the m, is y2 minus y1 over x2 minus x1, and we have the coordinates, which is -4, 5 and -6, 9. These are the coordinates. y2 minus y1, 9 minus 5 over x2 minus 6 minus x1. Okay, and this is gonna be 9 minus 5. What is 9 minus 5? This is negative, this is 4 over -6 minus 4, this is -2, and 4 divides -2 is equals to -2, so the gradient is -2. All right, so gradient of this line is -2, and what is the gradient of the line that is perpendicular? It is negative and reciprocal, it is 1/2. So the gradient of the tangent is 1/2, so y minus y naught equals to m is 1/2, and x minus x naught, it becomes +6. So this is going to be the equation of tangent, or if we can arrange in the form y equals to 1/2x plus 6/2 and plus 9. So 2 times 3 is 6, and 3 plus 9 is 12. So here y equals to half x plus 12. That is the equation of tangent to the circle at the point. Now for part B, find the equation of circle in the form of this. Okay, so we have the formula for equation of a circle, which is x minus a whole square plus y minus b whole square equals to radius square. What is AB? AB is the center of a circle, right? And we have given the center. The center is -4 and 5. Okay, so we have x minus -4 whole square plus y minus 5 whole square equals to radius we have given is √20 units, and radius square is √20 is the radius and its whole square. So this is x plus 4 whole square plus y minus 5 whole square equals to 20. Let me open the square. X square, 4 square is 16, plus 2 times x times 4. 2 times 4 is 8x, plus y square, 5 square is 25, minus 2 times 5 times y, which is 10y, equals to 20. So x square plus y square plus 8x minus 10y, and c would be plus 16 plus 25 and minus 20. This is equals to 0. Let me simplify. 16, 25 and 20, 21. So we can say the equation of circle in that form is x square plus y square plus 8x minus 10y and plus 21, this is equals to 0. Now for part C, find the value of theta correct to 4 significant figure. What is theta? Theta is the angle between AC and B. ACB, this is angle theta. So look at the triangle ABC. We have AC, we have BC. We don't know what is AB. When we know the length of AB, we can apply the law of cosine to get theta. Let me solve the coordinates of AB. Okay. Work on the coordinates of AB. Coordinates of A and B. As we know that AB, the circle intersects the y-axis at point AB. It means the x coordinate should be equals to 0. The circle intersect the y-axis at point AB. So this is a circle. It intersect the y-axis at point AB. So the x should be equals to 0 in this equation of circle. Let me write down the equation of circle. X square plus y square plus 8x minus 10y plus 21 equals to 0. Right? It intersect y-axis at A and B, that is x is equals to 0 when it intersect the y-axis. So the x is 0, y square minus 10y plus 21, this is equals to 0. Let me factorize this. Okay, 21, 3 times 7 is 21, minus 3 minus 7 is minus 10, minus 3y minus 7y plus 21 equals to 0. Y is common, y minus 3 is a factor, negative 7 is common, y minus 3 is a factor equals to 0. So factors are y minus 3 and y minus 7. Put both factors separately equals to 0. Y minus 3 equals to 0 and y minus 7 equals to 0. And from here y value is 3 and y value is 7. Got it. Okay, now we are left with, okay, yeah, we have A and B. So A, 3 and 7. So obviously this y value is 3 and here this y value is 7, right? So we can say A is 0, 7 and B is 0, 3. It's lower, right? Now what is the length of between AB? Between 7 and 3, 3, 4, 5, 6, 7. The difference is 4 units. So this length is 4 units. Now we have to work for theta. Okay, let me draw this triangle separately on this page and work on theta. Okay, let me say this is, okay, this is A, this is B, and this is C. This is 4, this is root 20, this is root 20, and this is theta that we have to work on, right? Apply law of cosine. Law of cosine. Okay, so we have to find this theta and its front side. We can take its square equals to root 20 its square plus root 20 its square minus 2 times root 20 into root 20 and cos of that angle theta, right? This is 16 equals to 20 plus 20 minus root 20 times root 20, this is just 20, and times by 2 is 40, minus 40 cos of theta. 16 equals to 40 minus 40 cos theta. So 16 minus 40 equals to negative of 40 cos theta. Shifting the 40 on the other side, 16 take away 40 would be negative 24 divides negative 40. This is equals to cos of theta. Okay, divides negative 40. This is 3 by 5. So cos theta is 3 by 5. And what is theta? Which is cos inverse of 3 by 5. It must be in radians, we have given in the question. My calculator is in degrees. Let me convert it into radian mode first and then find out cos inverse 3 by 5, which is 0.92 up to 4 significant figures. This is 0.927 1, 2, 3, 4 significant figure. This would be 3, rounded to 3. Yes, this is a value of theta. Now for part D, find the parameter and the area of the segment shaded in the diagram. The parameter and the area. So first work on the parameter. This is this straight length AB and this arc length AB. This would be the parameter. We have to add them up, right? So the parameter is length AB plus arc length AB. Okay, so we have AB 4 units and the arc length is radius times theta. So radius we have is root 20 and theta we got is 0.9273. Find out the parameter. Let me simplify this. Times it by root 20. Okay, and add 4. This is 8.15 if I round it. The parameter is 8.15, right? Now work on the area. Area of shaded region. So to get the area of a shaded region, as you can see in the diagram, first we have to find area of sector of a circle ACB, this sector, and then subtract this triangle because triangle is not shaded, right? So this would be A equals to area of sector minus area of triangle ACB, right? Area of a sector has a formula, half radius square and theta minus half, the two sides are AC, BC and sine of theta, right? So this is half, the radius is root 20 and its whole square, the theta is 0.9273 minus half, AC is root 20, BC is root 20 and sine of 0.9273. Let me calculate this. Root 20 square is just left with 20 and 2 times 10 is 20. So 0.9273 times by 10 is this 9.273. Okay, this next root 20 and root 20, we're just left with 20 divided by 2, which is 10, and then times it by sine of this in radians. It's in radians. Sine 0.9273 times by 10 is 8.000000. Okay, so 9.273 subtract answer. This is 1.27. 1.27 unit square is the area and that is the parameter. Question number 11. The diagram shows the curve with the equation this for x is greater than 0, positive values. The curve crosses the x-axis at points A and B. A and B, the curve crossed the x-axis, it means the y components are 0 and has a minimum point at A, M. Number A, find the exact coordinates of M. Okay, so whenever we have to find the minimum point, we have to put y prime equals to 0 and solve for x and y. So let me solve for y prime. We have y prime, 2 is outside. The derivative, we can calculate it. 2 is a constant term, its derivative, we have to apply the power rule. So first we write down the power. The base function is x and its power minus 1. And the derivative of x is just 1. Minus 3 is a constant, applying the power rule. Power, base function, power minus 1, the derivative of base function, and the derivative of 1 is just 0. So y prime, this is going to be negative 4 over 3. Okay, minus 2 by 3 and minus 1. Minus 2 by 3 and minus 1. This is minus 5 by 3. X power is minus 5 by 3. This 3 and this 3 is cancelled, minus is cancelled with minus, so it is plus x to the power minus 1 by 3 and minus 1. This is minus 4 by 3. Okay. This is y prime, and for minimum, we have to put y prime equals to 0. Okay, so minus 4 over 3 x to the power minus 5 by 3 and plus x to the power minus 4 by 3. This should be equals to 0. All right, let me write this. Minus 4 by 3, this x to the power minus 4 by 3 and x to the power minus 1 by 3. When bases are same, we can add the powers. 3 and 3 is as it is, minus 5, minus 4 minus 1 would be minus 5 plus x to the power minus 4 by 3. This is equals to 0. We can take x to the power minus 4 by 3 common. We are left with minus 4 by 3, x to the power minus 1 by 3 plus 1. This is equals to 0. Now x to the power minus 4 by 3 is equals to 0, and from here x is equals to 0. The coordinate of m never be equals to 0, right? So we are not taking the x coordinate of m is not equals to 0. As you can see, the x should be positive and y should be negative. Okay, the next is minus 4 by 3, x to the power minus 1 by 3 plus 1. This is equals to 0. So minus 4 by 3, x to the power minus 1 by 3, this is equals to negative 1. Minus is cancelled with minus. Okay, so to solve for x, we have to multiply both sides by 3 by 4 with the reciprocal. So x to the power minus 1 by 3 would be equals to 1 times 3 by 4 is 3 by 4, right? Okay, and we can say 1 over x to the power 1 by 3. This would be equals to 3 by 4 again. Now in the next step, what we have to do, we need to solve for x, we have to do the reciprocal on both sides, right? Reciprocating both sides, we have x power 1 by 3 over 1, and this is 4 over 3, right? Now taking cube roots on both sides, x power 1 by 3 cubic power times 3, and 4 over 3, its cubic power is 3. So 3 is cancelled with 3, so x is 4 cube is 64 and 3 cube is 27. So this is the x coordinate of m, which is 64 over 27 is 2.37, 2.4 we can say. So now find out the y coordinate. So what is the y coordinate? We have to substitute x into the equation to get the y. So 2x is 64 over 27 to the power minus 2 by 3, minus 3x is 64 over 27 to the power of minus 1 by 3, and plus 1. I substitute this into the equation of curve, right? Okay, let me simplify this. 64 over 27, its power is minus 2 by 3, 9 over 16, and times by 2 is 9 by 8. Okay, 64 over 27 and its power is minus 1 by 3, and times minus 3 is minus 9 by 4, and add 1. 9 by 8 minus 9 by 4 plus 1, this is minus 1 by 8. So y is equals to negative 1 over 8. So we can say the coordinates of m are 64 over 27 and the y is minus 1 over 8. This is a maximum, the exact coordinates of the minimum point. Now for part B, find the area of the region bounded by the curve and the line segment AB. Okay, area of a region that is bounded by this curve and the line segment AB. So first we have to find the coordinates of AB. The curve crossed the x-axis at point A and B. This is a curve, it crossed the x-axis at point AB, means that when it is crossing the x-axis, the y component of this curve is equals to 0. So we have the curve which is y equals to 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1, and it cross x-axis, it means y component is equals to 0. Y equals to 0. So we can say 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1, this is equals to 0, right? So let us suppose that t is equals to x to the power minus 1 by 3 I'm taking to make it easy. So now this is 2x square and minus 3x plus 1 equals to 0. So not x, this is t. Taking the square of t is minus 2 by 3. Okay, so let me simplify. 2 times 1 is 2, minus 2 minus 1 is minus 3. So 2t square minus 2t minus t plus 1 equals to 0. 2 and t is common, t minus 1 is left, minus 1 is common, t minus 1 is left equals to 0. So the two factors are 2t minus 1 and t minus 1 equals to 0, right? So putting the factors separately equals to 0, we will get the two values of t. So here t is 1 by 2 and here t is equals to 1. Now put it back, t is x to the power minus 1 by 3. X to the power minus 1 by 3 is 1 by 2 and x to the power minus 1 by 3 is 1, right? Or we can say 1 over x to the power 1 by 3 is half and 1 over x to the power 1 by 3 is 1, right? Do the reciprocal, x power 1 by 3 is 2 and x power 1 by 3, 1 by 1 is just 1. So taking cubes on both sides, x is equals to 2 cube and here x is equals to 1 cube, x is equals to 8 and x is equals to 1. These are the two solutions, 8 and 1, right? So the coordinate, the point x coordinates of a and b. So a is 1 0 and b is 8 0. All right, and this, the line AB, as you know, this is the horizontal line. This line is y equals to 0. So we can say that the line AB is basically y equals to 0. Right, now we have to find the area of the region bounded by the curve and the line. So line is at the top of the curve. So integrate the line, subtract, integrate the curve. Okay. So we can say area is line minus curve. So integration of the line is y equals to 0 from 1 to 8 dx minus integration of 1 to 8 of the curve, which is 2x to the power of minus 2 by 3 minus 3x to the power minus 1 by 3 and negative plus 1 dx. Okay, and we know that the integration of 0 is just 0. Subtract. When we have a definite integral, the integration of 0 is 0, but when we have an indefinite integral, its integration is just a constant. Let me apply the integration. 2 is as it is, x to the power minus 2 by 3 plus 1 over minus 2 by 3 plus 1. Okay, minus 3 is outside, x to the power minus 1 by 3 plus 1 over minus 1 by 3 plus 1, and its integration is x. It's a definite integral, so we are not adding the constant of integration. The upper and lower limits are 1 to 8. Further simplification I'm gonna do over here. Here we have area. This is negative is outside. 2x to the power minus 2 by 3 plus 1 minus 2 by 3 plus 1 is 1 by 3. 1 by 3 over 1 by 3 minus 3 minus 1 by 3 plus 1, sorry, minus 1 by 3 and plus 1 is 2 by 3. 2 by 3 over 2 by 3 plus x. 1 to 8 are the limits, sorry, not infinity, it's 8. Yes. Okay, further simplification, area is going to be minus 2 times 3 over 1 is just 3, x power 1 by 3 minus 3, 2 by 3 is 3 by 2, x to the power of 2 by 3 plus x, 1 to 8. Area, this is equals to negative 6x power 1 by 3 minus 3 times 3 is 9 by 2, x power 2 by 3 plus x, 1 to 8. Now let me plug the limits, the upper and the lower limit. So area is negative, the upper limit is 8, I'm plugging over here 6, 8, its power is 1 by 3 minus 9 by 2, 8, its power is 2 by 3 plus 8, minus the lower limit. This minus and this minus becomes plus. 6, 1 power anything is 1, minus 9 by 2, 1 power anything is 1, plus 1. This is my lower limit. So area is equals to negative 8 power 1 by 3 is 2 times of 6 is 12. 8 to the power 2 by 3 times 4. Sorry. 8 to the power 2 by 3 times 9 divided by 2 is 18 plus 8. Plus we have 6 plus 1 would be 7 and minus 9 by 2 plus 6 plus 1. This is 5 by 2. Now let me simplify. 12 minus 18 plus 8. This is 2. So minus 2 and plus 5 by 2. That would be the area. Okay, 5 by 2 minus 2. Sorry, 5 by 2 minus 2. This is 0.5. 1 by 2 is the area or 0.5. Right. So that was the last question of our paper. If you have any queries, please let me know in the comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.